Okay, guys, I'm jumping in though. We're just going to recap quickly what you did on Monday. To save time, I'm just going to do it. Hopefully you're listening. And if you are feeling stuck after what I do now, it means you need to go and watch one. You need to go and watch Monday's video. Right, so on Monday, what you guys spoke about was the distributive law of exponents. Now, the distributive law of exponents tells us that when we have a bracket raised to an exponent, we need to multiply the outside exponent to all of the exponents inside. Now, very importantly, you always multiply exponent with exponent. We never, ever multiply exponent with coefficient. Exponent with exponent. So because we are working with exponents, because we are distributing in an exponent, you only ever multiply the exponents. So what I mean by that is we are not going to multiply this 3 by the coefficient. That is not multiplying exponent with exponent. What we do know, however, is that this coefficient of 3 does actually have an invisible exponent of 1. We don't write it there, but we know it's there. And so when we distribute this 3 into our bracket, we are going to distribute it to all exponents inside our bracket. That means that I'm going to end up with 3 to the power 1 times 3 and x to the power 8 times 3. Again, hopefully what you're seeing is that I am only multiplying exponents with exponents. That is very, very important. Once we've got that, we know that 1 times 3 is 3. So we've got 3 to the power 3. And we know that 8 times 3 is 24. Now 3 to the power 3, you could leave it like this, but we always try and write it as a number. 3 to the power 3 actually means 3 times 3 times 3. And 3 times 3 times 3 is 27. So that whole initial bracket of 3x to the power 8 cubed simplifies to 27x to the power 4. So Teto, very nicely done. Well done on putting that there on the chat. But when we distribute, when we apply the distributive law, we are multiplying exponents with exponents. So this is very, very important to remember for ourselves. Right, so I'll wait there for a second if you want to take a screenshot. We're going to have a look at another example. Just to recap what you should know. Excuse me. Alrighty, hoping you've got your screenshots, grade 8s. Last 2 seconds. Right. So if we have a look at question 2, difference here is now we've got a fraction, but that doesn't change what we need to do. My rule says multiply the exponents with the exponent. Now remember, this coefficient of 2 does have an exponent of 1. So I am going to multiply the exponent of 9 with the exponent of 2, the exponent of 9 with the exponent of 1, but I mustn't forget about this exponent of 5 at the bottom. It's still there. I still need to apply my distributive law. This therefore means that I am ending up with a situation of 2 to the power 1 times 9, x to the power 2 times 9, all over y to the power 5 times 9. Now, guys, this step over here, you don't have to show the multiplication. You can do that multiplication in your head on a calculator, and you can go straight to the step where you've simplified your exponents. So you can go straight to, that's a weird looking 2, but anyways, 2 to the power 9, x to the power 18, all over y to the power 45. So you don't need to show the step. You are obviously welcome to. There's no saying that you are not allowed to show the step. And if you feel more comfortable doing that, please do, but you don't have to. Now, again, it's always nice to try and write the number as a number. 2 to the power 9 is 512. X to the power 18 all over y to the power 45. And so we have simplified our fraction there. Right, so again, I'm going to wait to take a screenshot. I see there's a question. If there is a number outside the brackets, do we multiply the exponent with the number and its exponent? How do we calculate it? So that is going to be our next example, Zintle. So hang on. Let's do the next example. If it's still confusing, then just let me know and I'll try and explain it again. I'm just waiting for everyone to take a screenshot. And then we're going to have a look at one more example, and then we are going to, I'm just taking a picture of my cat sleeping because they're quite cute. And then we're going to move on, just in case you wanted to see, because it's been a day and I need some cuteness in my life. Right. Last example. So simply listen up. Hopefully this is going to explain what's going on. So Tohira, just quickly, I distribute this exponent outside. So I distribute this exponent of 9 to every single exponent inside my bracket. So that is why all of these are being multiplied by the exponent outside. That is what the distributive law says to me. And so once I've multiplied, I'm able to simplify to get the answer. Alrighty. So if we have a look at example 3, guys, like I say, hopefully this is going to answer your questions and clear. We now have a situation where we have got a coefficient to the bracket. Now remember, we only distribute an exponent to the things inside the bracket. So because this -3 is not inside the bracket, I am not going to distribute the exponent of 3 to it. So the 3 is only being distributed to what is inside the bracket. This 3 only applies to this bracket. So I'm going to leave the -3 there. It doesn't go anywhere. I'm just not dealing with it at this point in time. And now I'm going to distribute. So I've got x to the power 3 times 3, y to the power 5 times 3, and z to the power 8 times 3. Again, my -3 is going to stay there. I don't do anything with it. 3 times 3 is 9. 5 times 5 is 15. Z to the power 8 times 3 is 24. So this -3 coefficient just stayed exactly what it was. It wasn't in any way affected by the exponent. And so we will not apply the exponent to it because it is not inside the bracket. Just going to make a little note here to remind us. So the -3, I don't know why I chose to write out the word negative. We'll try that again. So -3 is not in the bracket, therefore not affected by the exponent. I hope that has explained it for you. If it hasn't, like I say, just let me know. I'm going to stop here for you to take screenshots. I'm also going to stop here in case anyone has a question before we move on to today's work of dealing with the power of 0. So if you do have questions, you can raise your hand. At this point, you can raise your hand and I will answer those. Sisipo?
Ma'am?
Yes.
So I was going to ask if there's a negative and then a bracket and a negative. How would it be a negative or positive?
Oh, excuse me. Okay, so good question. I'm going to do a relatively basic example just because there's no need to make it long. So let's say we had the -3 and then we had -2x² to the power 2, right?
Yes, ma'am.
So what we need to remember is that this situation over here is telling me that I am multiplying the -2x² twice. Do you agree with that?
Yes, ma'am, twice.
Right, now, if I'm multiplying a negative by a negative, what do I end up with?
A positive.
Good, well done. So actually what I have here is -3 to the power positive 2 squared, because remember, I'm distributing that to the exponent, and
Yes,
I'm
ma'am.
distributing that to the x. So I'll have x to the power 4.
4.
So now I've got negative 3 times 2 squared, which is
4.
2 squared, which is 4, x to the power 4. And now I can distribute, or now I can multiply those numbers. So negative 3 times positive 4 is negative 12,
Negative 12.
x to the power 4.
Oh, okay.
Okay. However, I just want to show you something else. If, however, this exponent had been an odd number, so if right at the start, this had been exactly the same, but the exponent outside had been a cube, this is now saying that I'm multiplying, oh, gracious me, that I'm multiplying this minus 2x squared 3 times. Now, if I'm multiplying 3 negatives, what sign do I end up with?
Negative.
Good. So now we would have negative 3 times negative, and I multiply my exponent. 2 cubed x to the power 6.
Yeah.
Now, excuse me, 2 cubed we know is 8. So we've got negative 8 to the power 6. And now I've got a negative 3 times a negative 8. So that becomes positive.
Positive.
20.
Oh, okay. I see now.
Okay. Good question. Okay, so guys, what I'm actually going to do, because that was actually a very, very nice and important question, I'm going to leave that up there in case anyone wants to screenshot all of that.
Ma'am?
Yes.
What if the exponent, like there's no exponent outside the brackets?
So if there's no exponent outside the bracket, we obviously won't distribute, and then you would multiply the negative 3 and the negative 2 to get positive 6.
Oh, just the signs.
Yeah.
Okay.
Exactly.
Okay.
Good.
Thank you, ma'am.
Good question, guys. Okay, so I'm just waiting for people to take screenshots if necessary. I see one more hand, and then we're going to have a look at today's lesson. Fair question?
Yeah, ma'am. Hi.
Hi.
So what if outside the bracket you have a negative exponent?
Okay, so we don't deal with negative exponents in grade 8. If it was a negative exponent, you would still just distribute the exponent inside. You would just need to remember that you're multiplying by a negative. And then next year, we're going to learn how to actually deal with those negatives.
Okay, ma'am. Thanks.
Okay. Right, guys. So let us, I don't know, I'm about to mute myself. So Hira, last question before we move on. There should be a pop-up to unmute yourself. There we go.
Hi, I'm still confused with the pot in dark green. I still don't understand it.
Okay, so firstly, am I pronouncing your name correctly?
Yes.
Okay, right. So the stuff in dark green, what I'm trying to show you here is that, whenever you have got an odd exponent, so the fact that this is a 3, it means that you're multiplying 3 negatives if there is a negative inside the bracket. And the second we're multiplying 3 negatives, you end up with a negative. And so that is still going to be a negative. So I'm just trying to get across the fact that if your exponent is odd and there's a negative inside the bracket, it's going to stay negative. However, if your exponent is even, like what I had written here in the light green, whoopsie daisies, if your exponent is even, negative times a negative is a positive. So that's why that's a positive 2 squared.
Oh, now I understand.
Good. Okay, Motabang, last one, and then I'm moving on.
I'm sorry, my computer logged off. I'm confused.
Okay, you're gonna need to watch the video. Unfortunately, if you logged off, then I can't go back and re-explain anything. This is all revision from Monday. So this is basically what you did on Monday's lesson.
Okay, ma'am.
Yeah. Oh, sorry, guys. All right, so guys, let's get on here. So remember, rainbow block means that we are doing some sort of rule or definition that we need to know. And this is what today is all about, the power of 0. Oopsie daisies. Okay, so let's get a good color going on here. Power of 0. This is today's rule that we need to learn and that we need to know. Right, when we are dealing with the power of 0, it's very important to understand why the power of 0 results in the answer it does. So for us to do that, I'm going to hopefully explain this in a way that will make sense for why x to the power of 0 or anything to the power of 0 is what it is. All right, so if we have, for example, x to the power 3 divided by x to the power 3. If we apply our exponent laws tell us that we need to subtract the exponents in order to simplify. And so this gives us x to the power of 0. But again, we need to know what that means. So let's think about what we're actually doing here. If I sort of take this over, I am dividing x to the power of 3 by itself. So if I used a number and said 3 divided by 3, well, I know that's 1. If I said 7 divided by 7, I know that's 1. If I said negative 1,398 divided by negative 1,398, I get an answer of 1. So whenever we divide a value by itself, we get 1. Right, and this is now the basis of our law. So Lawrence has put in the chat there what they've learned. We can see that we are dividing x cubed by itself. So mathematically, according to what we've just seen, that must be an answer of 1. So x to the power 3 divided by x to the power 3. We'll get there in the end. Come on, hello. X to the power 3 must be 1 because I'm dividing a value by itself. But we also saw that x divided by 3, or x to the power of 3 divided by x to the power of 3 is 0. Now, if these two answers are coming from exactly the same sum, they must be the same. And so our definition or our rule that we are needing to learn here is the fact that x to the power of 0 is equal to 1. And what this translates to as our rule is that any value raised to the power of 0 is equal to 1. Let's maybe not do that. Is equal to 1. So 3 to the power of 0 is 1. Y to the power of 0 is 1. I don't know, 17 to the power of 0 is 1. Any value raised to the power of 0 is 1. And so that is our next or final definition that we need to know about exponents in grade 8. Right, so again, if we take x to the power 3 and divide x to the power 3, according to our exponent laws, we would subtract the exponents and get 0. But we also know that anytime I divide something by itself, I get 1. And so our rule says, anytime I've got something to the power of 0, I am actually working with 1. Right, I want to try and do a few examples. Hopefully we can have a brain break because I think I need one as well. Let's do 1 or 2 examples and see how we go, especially for those of you that are saying you're confused. Hopefully once we've done some examples, you will no longer be as confused. So take a screenshot of this, and then we're going to look at 1 or 2 examples. Will we ever do scientific notation? Honestly, scientific notation is not a huge section, so we probably won't. I can maybe put a question into our bootcamp session and we can deal with it there, but it's not a big session. It's not a big section. And so because we only have 2 lessons every week, I just don't include it because it's not the most important thing in the world. All right, guys, so let's have a look at some examples here. So example A, we've got a bracket raised to our exponent. So we can apply our distributive law. This is nothing new. You know, when you've got a bracket raised to an exponent, that's what you do. So we are going to multiply the 0 with the 6. So that leaves us with x to the power 6 times 0. Now we know that anything multiplied by 0 is actually just 0. And so because we know from our definition that any value to the power of 0 is 1, that's our rule, we now know that this value simplified is 1. All right, so even though we applied law 3, or even though we applied the distributive law, we are still applying what we know about an exponent of 0. Because we had x to the power of 0, we have got a value of 1. Sorry, I've got myself distracted answering a question. Alrighty, guys, so let's try another example. If we have a look at question B, nothing's changing here. Oh, for the fact that this is a weird situation that I've got going on here. Sorry, let me just fix this. There we go. All right, so nothing's changing here in terms of my method that I need to use. My rule says, my distributive law says, multiply the exponent outside to all of the exponents inside. Remember, this 2 does have an exponent of 1. So that also needs to be multiplied. So what I have here is 2 to the power 1 times 0, x to the power 4 times 0, and y to the power 6 times 0. All of them are being multiplied by 0. Again, 0 times anything, so 0 times any value is equal to 0. So this is just, no. This is just 2 to the power 0, x to the power 0, y to the power 0. And because we know our rule is that everything's fine. Because we know our rule is that, I'm going to try this one more time. Any value to the power of 0 is equal to 1. We know that all of these, 2 to the power of 0, x to the power of 0, y to the power of 0, are equal to 1. And we then know that 1 times 1 times 1 is just 1. Okay, so really importantly, anytime you have something to the power of 0, you actually just have a value of 1. That's the takeaway rule that you need to know. So this thing that I've written down here, whoopsie daisies, any value to the power of 0 is equal to 1. Take your screenshots. Okay. I think it's time for a brain break. I'm going to be honest. I think I need one. I think you need one. So. Screenshots. Let's go. Nays already up and stretching. Here's your brain break for the day. A little bit different. What's happening here with this brain break is, I'm just going to move this joke over, is you have to make the word, or you have to figure out what the word is at the bottom. So that is what our brain break is. There's your joke. What do mathematicians do in a blizzard? they make snow angels. They don't make snow angels. I just ruined my own joke. They make snow angles. Right, so guys, I want you to try the brain break. So what you need to do is you need to figure out what letter each of these flags represents from the list given here on the side so that you can figure out what the final word down at the bottom is. Okay, so look at your operations. I would start, if you need a bit of a hint, with this column over here. Something times 12 is 24. So you need to know, or you need to figure out what that something is.
Let's go, my people. Let's go. We can do this. Yeah, I also love the joke. Let's go, let's go, let's go. We can help each other on the charts. But we are basically looking for the one that will say the correct word. Let's go, my people. So remember, we are forming a word. That's what we are doing. We are forming a word. So you got, I don't know maps that well, but I mean, something multiplied by 12 needs to give you 22. But also something multiplied by something needs to give you 8. So what is a number that we can multiply with 12 that gives us 24? So find that number. When you find it, it means you'll find a letter to put where that map flag-ish is. So look at where 2 is. So if everybody agrees that that's 2, you must check the letter of 2 and put it where the flag of that country is. Yeah, I really don't know my flags, guys. Yeah, forgive me. So after that, after that, you need to ensure that you find out that number that you got multiplied by the flag of America, which is the only one that I know, needs to give you 8. But also that flag of America's number multiplied by the other flag that I don't know what it is, needs to give you 24. Okay, so that's how we can form a word there. Okay, my people.
I see quite a few of the words coming through. So very nicely done. I see who was the first person to get it. Dun, 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 dun. Brew. No. Yo, guys.
Actually, most of you got it correct, actually. Yeah.
So I think let me just do it so that we're not wasting time. Right, guys.
Yeah.
So if we have a look, I gave you a hint. Those people who are not getting it, you're not listening to the instructions, but I'm about to explain it. So listen. We have got, I told you to start with this first column. So we've got something times 12 equals 24, which means this flag with the star on it is 2. So that means down here, I can fill in whatever letter 2 is, which is an L. Now, because I know 2, I can work out America's flag because 2 times 4 gives me 8. So America is 4, which is O. So we've got BO. This flag over here, we know we've got 12 plus something gives me 18. That would be 6. And so we fill in the letter for 6, which is W. So the answer, the word that you should get is bowl. Like a bowl that you eat out of. Right, so that's just a little brain break. Those of you who are confused, brain break is just quite literally what it says. It's just a little break before we carry on with our work. Right, which is exactly what we're going to do now. So if we go back up to C, hopefully because everyone was listening to me earlier, we know how to do question C. So my distributive law tells me, I'm not going to do the whole thing. You're going to try it by yourselves. I'm just going to help a little bit. The distributive law says to us that we need to multiply the outside exponent to all the exponents inside my bracket. Now remember, this -3 has an exponent of 1. This y has an exponent of 1. This 2 is not in my bracket, so we do not distribute to it. So this 0 is only going to distribute to the exponents inside my bracket. So I want you to give it a try. Answers on the chat, and we'll see how we go. Right, would anyone like to raise their hand to explain or tell us how they got their answer? Fatima? No? Teto?
Hello, ma'am.
Hi.
So ma'am, since 2 wasn't inside the brackets, I ignored it for a while. So I ended up just focusing on what was in the brackets.
Cool.
So -3 to the power of 1 times 0 which equals 1. So I just put that down in brackets. Then x to the power of 3 times 0 also equals 1. So I just put that down in brackets too. And then y 1 to the power of 1 times 0 also equals 1. Yeah.
Yeah,
also
no,
equals-
you're right. Yeah.
So I ended up having 2 times 1 times 1 times 1. And that
Good.
ended up being 2.
Perfect. Okay, so guys, I just want to explain just in case anyone was confused. When Teto was saying 1 right at the start, essentially we were already going basically from the fact that this situation is going to equal 1. That is fine. You do not need to show all of this multiplication and simplification. If you know that it's 1, you can go straight to 1. That's not an issue. I've expanded it a little bit just so that you can see why all of them are 1. But remember, anything to the power of 0 is 1. And because all of those are to the power of 0, they all have a value of 1. Good, very nice. Right, I want you to try D for me. Oh, sorry, guys. Right, so try D. Answers on the chat. Let's see how we go. Oh. Right, anyone want to raise their hand in order to explain it? Sipasihle, I see your hand is up. Are you explaining it for us?
I wanted to ask for question C, ma'am. Like,
Mhm.
how did you get the answer? Because what about the -3?
Okay, so remember this -3 is raised, whoopsie daisy, sorry, let's get this whole situation right. -3 is raised to the power of 0. Anything, even if it's negative, to the power of 0 is 1. So because of that exponent 0, it's 1. And so
1.
we've got 1 times 1 times 1.
Oh, thank you, ma'am.
There's ya. Okay, so
I need to understand it more.
Watobe, do you want to explain?
Yes, please, ma'am.
Okay, I'm ready.
So x to the power of 0 is 1, and any letter next to a number is times. So 2 times 1 is -2.
Perfect. Well done. Okay, so guys, importantly there, what we need to see is that it is only the x that has the power of 0. There's no brackets like in the last examples. So it's only x to the power of 0, which is why we get 1 there. We've then got the -2 times the 1. And so exactly as Boitu said, -2 is our answer. Right, I'm going to let you take screenshots. If you have questions, now is the time to raise your hand. Sissy4?
So, ma'am,
Yeah.
if a negative is raised to a power of 0, will it always be positive?
Yes, as long as that negative is in the bracket. So what I mean by that is, let's do this. So what I mean by that is you've got two scenarios. You can either have a negative outside the bracket and then to the power of 0, which means
Yes,
that this is only going to distribute to that power of 1. So that negative stays there because it's not inside the bracket. And then we've got 3 to the power of 0. So that would be -1. However,
Okay.
if the negative is inside the bracket, then that whole thing is equal to 1.
Oh, okay. Thank you, ma'am.
Okay, good question. You're on fire tonight. Tohira, question? Tohira, you should be able to unmute yourself. Okay, don't know what's happening. You might just need to pop your
Your
question
answer
in the
or your
chat.
question in the chat. Yes, Toyera. Oh, there we go.
Oh, there we go.
Ma'am,
Yes.
can ma'am just explain that again all over, please?
Which part again?
Everything.
No, I need to know specifically which part. I can't do everything again. If you need everything explained again, then I would suggest watching the video.
Okay.
Okay. But yeah, watch the video. Sorry, I don't know what's happening. Okay, I don't know. Okay, right, guys. So I want you to try E for me. Again, there's no bracket, so be careful. Only consider which value is to the power of 0. So Tohira, if you were confused about the last one, give this one a try, but this is very similar. So hopefully this will make sense when we go through this one. But I want you guys to try this for me. Excuse me. Think very carefully about which bases are to the power of 0. Remember, answers on the chat. Yo, me and technology are just having moments tonight. I don't know if anyone can hear my cats running around in the background, but they are chaotic tonight.
We do see those answers coming, y'all. We're just
Good,
waiting
guys.
for majority of you, majority of you to put answers on. Y'all are amazing.
Doing really nicely.
And Hendrik, we haven't marked it yet. Okay, so don't panic, guys. Teacher Sam will walk us through it. Those that know the answer, they can put it on the chat, even if you don't know what you have written. And then we're gonna mark with Teacher Sam as Teacher Sam corrects it on the board. Okay. So don't panic much, because of course you will see different kinds of answers on the chats. Doesn't mean it's right, doesn't mean it's wrong. Okay, it's what people have.
Right, guys. So would anyone like to raise their hand in order to explain how they got this answer? And this is quite a nice one. And again, guys, if you were confused about the last one, listen to this explanation. Okay. Motabang, what do we do here?
Ma'am, I saw that 3 is to the power of 1, and also I said 3 to the power of 1 times x to the power of 0 times y to the power of 2 times z to the power of 1.
Mm-hmm.
Then I said x to the power of 0 is 1. So I said 3 times 1 times y to the power of 2 times z to the power of 1. And it's 3 times y to the power of 2 times z.
Good.
I mean, Z.
Excellent. Well, that's Z. Perfect. Right, Motabang, very nice. So guys, again, very similar to the last example. It is only the x that is to the power of 0. So that means that is the only value that becomes 1. Everything else stays the same. Nothing changes with the others. It's still 3, it's still y squared, it's still z. Only that x to the power of 0 that became 1. So if you have a look then at question D, it's basically the same thing. Only x was to the power of 0. So that is the only thing that became 1. Excuse me. So we need to be very careful of when there's situations of distribution, like what we started with, or when there's situations where there's no distribution and there's only one base or certain bases to the power of 0. Remember, this isn't a quiz. Quizzes are based on Mondays and Wednesdays' work. Right, I'm just waiting for everyone to take a screenshot. Let's see if we can do one more. Just want to see what my next example is. Screenshots, guys. All right, so let's try question B. We're going to do it together just so that you can see what's going on. So question B here, we've got quite a little bit going on, but what we do notice is that we've got this power of 0 in the bottom. And so what that means is that every one of the exponents in my denominator, we need to distribute this 0 to all of them. Okay, so that means we are going to end up with the numerator stays the same, so 4xy cubed, but in our denominator, we're going to have 12 to the power of 0, x to the power of 0, and y to the power of 0. Now, guys, remember, all of these power of zeros actually mean 1. So in my denominator, 12 to the power of 0 is 1. X to the power of 0 is 1. Y to the power of 0 is 1. And so my numerator still hasn't changed because nothing is happening there. But all of my denominator is now 1. Now we know that 1 times 1 times 1 is 1. So we just have 4xy cubed over 1. And there's no need to write that denominator. If something is over 1, we don't have to write it as a fraction. And so what we have here is 4xy cubed. So again, because I had this distribution, because I had this 0 that I needed to distribute into my bracket, all of these exponents in my denominator become 0, and that means they all become 1. And anything over 1, we don't have to write as a fraction. Okay, so we need to be able to apply our exponents of 0 or our distribution laws, or really all of our laws, in sometimes multiple rules at the same time, and in situations where we're only applying, say, for example, now the distributive law to just our denominator. I'm going to wait here for you to take a screenshot. No problem. Right, guys, any questions? Now's the time to raise your hand. Nkululeko?
Hi, ma'am.
Hi.
And ma'am, may I ask here, why does 4xy to the power of 3 does not change?
Okay, so if we look at the original question, I'm just going to take off all my scribbles here. If we look at the original question, do you see that in the numerator, nothing is happening to the numerator? It's not like there's a bracket with an exponent or a power of 0. There's nothing actually that affects this numerator. And so because nothing happens to it, it has to stay exactly the same all the way through.
Yes.
Does that make sense?
Yes, ma'am. Thank you.
Good. Wandle?
Evening, ma'am.
Evening.
Ma'am, so my question is, so when a numerator does not have any brackets, it does not change.
No, the only time it might change is if, let's say, for example, I had 4xy cubed times, I don't know, 2xy, and then I had my denominator going on. So then you would need to multiply your numerator in order to get 8x squared y to the power 4, but then your whole denominator is still 1. So it's only if there is something extra happening in your numerator. It's being times by something, it's got a bracket with an exponent, something like that. Otherwise, it stays exactly as it is.
Oh, okay, ma'am. Thank you.
Good, well done. All right, so guys, I hope you've all got your screenshots.